All right, today we are going to be talking about the assembly of this plastic shredder. Now, let me make it clear, I am by no means an expert in shredder building. Probably you can tell just by even looking at the machine. If you know what the specs are for the Precious plastic shredder, this doesn't really look anything quite like that setup. But I don't really have a lot of experience building this kind of stuff. I'm certainly not a welder, I'm not a machinist or anything like that. So I was really trying to come at this with very little expertise in this area and try to build the shredder and see how far I could take it. And I think that this is going to be relevant to anybody who might be interested in building one of these machines from Precious Plastic by themselves with little experience. Some of the things you might think about, encounter. So let's take it away. Now, in a previous episode of this vlog, I went thoroughly through all the different components, so I'm going to focus today more on the actual assembly. This process began with gluing together 2 1/4-inch boards of plywood to get a 1.5-inch thick base. Once the glue was dry, my dad and I were ready to start laying out the pieces. We decided to start by positioning the gearbox since both the shredder and motor positions hinged around the gearbox. Next, the motor was going to need to be raised by over 3 inches to fit in the gearbox correctly, so we needed to cut out some spare wood in order to make a razor. Once they were cut and glued, we set it aside to dry and moved on to positioning the shredder. For the shredder, we needed to cut a large hole for the output and also make sure the bottom grate was removable without having to detach the whole shredder from the base. This took a bit of trial and error, partly because our jigsaw cuts weren't perfect, but it didn't take too long. Once the motor razor's glue had dried, we were ready to attach it. However, in addition to needing the 3 inches of height from the boards, we needed about 6 millimeters more in order to line things up perfectly. Enter the washers. Now, I don't have the clearest footage of this part. It was a little bit hard to show on camera, so let me look at the final result with you. I know this looks a little janky, but it's worked pretty well for us so far. After running the motor and gearbox together, things were in good order. The next logical thing to do was bolt down the shredder, attach the chain, and run our first test with all the moving parts. Now, obviously this shredder still needs a hopper in order to keep my fingers away and hold stuff down, but we just wanted to make sure that from a torque perspective, we were getting enough power to chew up the plastic to our satisfaction, which you can see it was doing. But without a hopper, it's not going to stay in place at all. With our first test successful, it was time to take some selfies with the shreds. I think these were my dad's first selfies ever. As I demonstrated last vlog, the hopper plan was to build a frame from aluminum with acrylic sheets to make it see-through. So we needed to saw out several pieces from a single 8-foot length of aluminum angle. Then we needed to drill holes through the aluminum for our rivets and screws. Now, after riveting a few times, we realized we had a couple of issues. Our rivets were a tad on the small size, but worse yet, it was cracking the acrylic sometimes, so we decided to try something else. We tried using some spare nuts and bolts I had lying around, and also used some 3D printed nuts and bolts to attach the hopper to the shredder itself. Both of these were mistakes. What happened is an aluminum bolt fell off of the hopper into the shredder, and that caused the plastic bolts to come off when the torque increased and left a little mark on the shredder right there. And furthermore, that left us with a misalignment on our left and right sides, which you may be able to see just slightly. This significantly increased the force required to even get it to rotate. After contacting the original builder of the shredder, he advised to us that we just loosen things up and try to see if we could get things realigned. Sure enough, that did end up doing the trick. We had to loosen things up on both sides, adjust here and there, but eventually things were rotating again. we still needed a way to safely attach the hopper though. I purchased some vibration-resistant nuts with rubber inlays, as well as some vibration-resistant screws. These create a dramatically tighter connection that prevents loosening when the machine is running. While we're at it, why not paint the hopper before we reassemble it? One last thing to do though, I needed to make a control box with my 3D printer, so I measured the switches and prepared one in Fusion 360. I forgot to record this part, but let's talk about 3D printing another time. We soldered up the switches, put them inside of the control box, and attached it to the frame. With our shredder fully assembled, we were off to the races. Even with the hopper in place, it took some pressure from above to push plastic through, but the results were satisfying. Now, I want to analyze how the shredder is currently operating more deeply, but first, let's talk at a higher level about the current design. The original precious plastic shredder is typically designed around a metallic frame and hopper, both of which involve a significant amount of cutting and welding. The motor gearbox combo is left pretty vague also, so it's on you to figure out. On the Teaching Tech YouTube channel, Michael took an approach using MDF board, which inspired my build. He ended up disassembling a winch as his motor source, but struggled a bit to couple it securely with the shredder. I sourced my motor and gearbox separately and chose a sprocket chain system to overcome needing perfect alignment between the shredder and gearbox. It also helped me overcome a metric imperial system difference between the two shaft diameters. The shredder is metric and everything else is imperial. So how have my design decisions impacted the final result? Well, number one, I'm currently dealing with significant vibration compared to what I would expect from a metal frame. I'm losing efficiency in the system and increasing my maintenance. Number two, the chain sprocket system works, but I don't think it's a good choice for systems with such a variable load or jam risks. Do you notice the skip in the chain? This came about after our aluminum bolt incident, which put significant strain on the machine. I'll be replacing this chain with a heavier duty version, but generally I don't intend to overload the machine and risk too much jamming as long as I'm using a sprocket solution. Otherwise, I'm pretty happy with the results. The single axis blade of the precious plastic shredder isn't great at sucking items in, so you need to pre-cut the plastic for best results, but that's not really anything specific to my design. I guess that's why the Shredder Pro exists. I consider this a V1 of the machine, sufficient to get me through my initial concept phase, but I want to consider significant enhancements for V2, both for efficiency and for safety. I hope to share another vlog with you soon about the next machine I built this summer.